So finding these slopes, let's remember our two steps. So the first thing I do is write it with the numerator and denominator. So 5 is the same thing as 5 over 1. I'll flip the numerator and denominator, so it ends up being 1/5. And then I can't forget my last step of flipping the sign. So it was positive, so now I'm going to make this negative. And this answer will be negative 1/5. You can't simplify it, that's it. Now the negative reciprocal of negative 3/4. So I'll just write it out in an easier way for me to see again. Now I want to flip the numerator and denominator. So 4 goes from the bottom to the top, 3 goes from the top to the bottom, and the negative will become a plus because I also have to reverse the sign. And that's it, because I can't simplify. The answer is positive 4/3. That's the slope of my perpendicular line. Now question number 3. If the slope is negative 1, this one might have been a little tricky for you, but the way we'd rewrite it is negative 1 over 1. You could do 2 over 2, 10 over 10, you could do a million over a million, and the same answer will happen. So 1 over 1, I can flip them or not, it's the same thing, where that's just going to be 1. And then negative, I change the negative to positive, and I get positive 1. So that's the slope for this equation. And finally, the slope of the perpendicular line, where the given slope is 1/8. So 1 over 8. Now step 1, I flip the numerator and denominator, so that ends up being 8 over 1. The 8 didn't copy. Let me write it again. Oh, it's horrible, but you get it. And then I want to flip the sign also, so it was positive, so now this is going to be negative. And I can simplify this a bit, because negative 8 over 1 is the same thing as negative 8. So that is the answer. All right. Now this next part of the lesson is more dense, because we're going to be looking at some VIPs on how to find equations of lines that are parallel or perpendicular, and where we're given a point. These steps are actually going to be the same for both ways, for parallel and perpendicular, except the way we do them is a little bit different because the slopes of these are different. The way what we covered earlier in the lesson, that's all going to come back right here. So we're going to start with parallel lines. What I want to do is write the equation of a line that is parallel to a given line. Here's my given line for this one, and goes through a given point. So I'm going to do that right here. Step 1, you want to find the slope, so identify what it is, and then rewrite the equation. And I'll go over that right now. So here's my equation of y equals 2x plus 3. Since I know the format of y equals mx plus b, I know that my slope is 2. So we go ahead and write that out separately so I can see it. And then to rewrite the equation, the way we want to rewrite it is getting rid of this specific b value. So plus 3, I don't know what the y-intercept is going to be for my parallel line when it goes to this point. So we're just going to rewrite it as this plus b. So what you're going to end up doing for this step is putting y equals 2x plus b. So you keep your m value and you change the y-intercept back to just this b. Now step 2 is you want to plug in the x and y values from your coordinate here. So where x equals 4 and y equals 7. So all you do is plug them in. Don't even solve them yet. Just do that for step 2, is plugging those values into the equation we just made right here. So the only variable left is b. And now, since b is our only variable, we can solve for it. So here we have 2 times 4 ends up being 8. So 7 equals 8 plus b. I want to get b all alone, so what I'm going to do is subtract 8 from both sides of this equation. So 8 plus b minus 8 just becomes b, and 7 minus 8 becomes negative 1. So we have b equals negative 1. And now step 4, putting it all together. So I have m and b, where m is 2 and b is negative 1. And that comes all together to say that y equals 2x minus 1. mx plus b, 2x minus 1. So that's how you do this for a parallel equation. Now, for perpendicular lines, it's the same steps, except we're going to have something different happen with the slope. So we have a different equation here. It's y equals negative 2/3 x minus 3, and the given point is negative 4, 2. So again, we're trying to find a line that is perpendicular to this given equation we have here, and this new line also has to go through that given point. So step 1 is the same of finding the slope, except this time, the slope of the perpendicular line is the negative reciprocal, so that thing we just went over. So you have to make sure to do that before moving on. So again, step 1 of flipping the numerator into denominator. So instead of 2 over 3, it's 3 over 2. And then the sign was negative, so it becomes positive. So the negative reciprocal is going to be 3 over 2. Then I want to rewrite the equation just like we did before, so I get rid of this b value of negative 3 and change it to just this plus b. So this is the equation we're going to use in the next step. Y equals 3/2 x plus b. So step 2 is the same thing, where we plug in the x and y values. So remember the point, we had that x equals negative 4 and y equals 2. And we don't solve it yet. All we want to do is make sure we plugged everything in correctly. So 2 equals 3/2 times negative 4 plus b. And then we're going to solve for b in this next step. So be careful with this fraction here, but negative 4 times 3/2 is negative 6. So we have 2 equals negative 6 plus b. Again, I want to isolate this plus b. So I'm going to get rid of this negative 6 by adding 6 to both sides. So negative 6 plus b plus 6 just becomes b. And then 2 plus 6 becomes 8, so it's 8 equals b. So now that we have m and b, we can do step 4 of putting it all together, where y equals mx plus b becomes y equals 3/2 x plus 8. So the same steps, but the big difference was step 1, for perpendicular lines, you have to use the negative reciprocal of the slope, whereas in parallel lines, all we had to do was just find what m was, and it was given to us, and it was really easy there. Now you're all going to do one example of each thing, so where you're finding it for parallel lines and we're finding it for perpendicular lines. And I'm going to put them as separate little slides, so you have all the space you need to write out your thinking. So just go ahead and do that on the next slide.